Hello viewers, again is Teacher Kariuki. We are back on our daily basis activity, that is doing mathematics together and simplifying maths. If it is your first time to be in this channel, there is a black button just on your screen. Click subscribe and then turn on the notification bell so that each and every time I update a new video or I upload a new video, you will always be updated. Let's keep on doing this together. Let's keep on motivating ourselves so that we can be better in mathematics day after day. So today there is a question here I want us to do, and this question is on indices, and I want us to simplify this question. And our question reads 27 to power 2 over 3 divide by 2 to power 4 over 32 to power negative 3 over 5. So we are expected to simplify this question. So how do we go about simplifying this question? So for us to simplify this question, we need to be familiar with the rules of indices. And these rules of indices are the ones that are going to help us simplify this question. So we have a law in indices that states that a to power m over n is equal to nth root of a to power m. Nth root of a to power m. Therefore, we can be able to apply this law to solve this one, and it is going to be 27 to power 2 over 3 is the same as saying cube root of 27 to power 2 divided by 2 to power 4 over our denominator is equal to 32 to power negative 3 over 5. The same can be simplified using this formula here or this law, and we can have the fifth root of 32 to power negative 3. So that is how we are going to simplify. So the cube root of 27, so you can use the factor tree method to find the cube root of 27, and you are going to find that the cube root of 27 is equal to 3. So it's going to be 3 to power 2 divided by 2 to power 4 over the cube root of 32, the fifth root, of 32 is equal to 2. So it's going to be 2 to power negative 3. 2 to power negative 3. So 3 squared is equal to 9. 9 divided by 2 to power 4. 2 to power 4 is equal to 16. 16 over 2 to power negative 3. 2 to power negative 3. 2 to power negative 3. Higher. So where we are now at, we have another row here. We have a number raised to a negative power. We have a row that states that a to power negative n is equal to 1 over a to power n. Therefore, 2 to power negative 3 is equal to 1 over 2 to power 3. That is equal to 1 over 8. So this is the same as 2 to power negative 1 over 3. So for us to simplify that, we are now going to continue it at this point, and we now have 9 divided by 16 divided by 1 over 8. This can be written the same as 9 over 16 divided by 1 over 8. It's the same. 9 divided by 16 is the same as 9 over 16. Then divide by 1 over 8. That is 1 over 8. So we can use the rule of multiplication here, or the rule of division that states that for us to work out this one, we need to reciprocate and have 8 over 1. And when we have that, by 8 1 by 8 2, and we are going to have our final answer as 9 over 2. And 9 over 2 is the same as 4.5. So we have already reached to the conclusion, and our answer is equal to 4.5. So generally, that is how we apply these rows of indices. And By applying that row, we are going to find our answer as 4.5. So you can take this as your second row. You can also take the first one that we used, that is a to power m over n is equal to n root of a to power m as our first row. Let me list down the rows and most of the commonly used rows in indices, so that as you continue with your revision, you are going to be familiar with them. So let's utilize this space and write down the rows used in indices. The rows used in indices. So we have rows of indices. Rows of indices. So we can start with the first one. We call it the multiplication law. We call it the multiplication law. Multiplication law. And multiplication law simply states that when we are multiplying two numbers, two numbers with a common base, and the power might be different or the same, this is equal to, the base remains as constant. Note that when there is a multiplication sign, then when we have a multiplication sign, we add the powers. So it's going to be m plus n. M plus n. That is our first row. Our second row is the division row, or what we call the quotient row. Our second row is the quotient row, and the second row being the quotient row states that a to power m divided by a to power n is equal to a to power m minus n. So we subtract the power, the base remains the same, we subtract the power. That is the second row. Then the third row, we have a to power m over n, a number raised to a power, that is a fraction, is the same as n root of a raised to power m. N root of a raised to power m. We can proceed to the fourth row. The fourth row is that when we have a number raised to a power that is a fraction, whose numerator is 1, when we have a number such as a raised to a negative power, is the same as 1 over a. We take the reciprocal of the number, then the power becomes automatically negative. We can have that as the fourth row. Our fifth row, we have what we call the zero index. And the zero index simply states that a to power 0 is equal to 1. This means that any number raised to power 0 is equivalent to 1. You can attempt that using your electronic calculator, and you are going to confirm that any number raised to power 0 is 1. So these are the commonly used laws in indices, and once you are familiar with this, there is no question you are going to fail based on indices. So I wish you all the best. I will make efforts to be uploading each and every video per day, so that we are going to keep on improving in our day-to-day activities. Thank you so much. Don't forget to click on the subscribe button. It's a black button on your right. Click that button written subscribe. Turn on the notification bell, so that each and every time I upload a new video, you'll always be updated, and we are going to continue making mathematics simpler and simpler each and every day. Thank you so much. Thank you for your support. I wish you all the best as you keep passing on your mathematics examination. Thank you so much.